Hey, hi guys. Thank you so much for joining us here at YouTube Live. For those who don't know about PyData yet, we are a non-profit educational program of non-focus, providing a forum for international community of users and developers of data analysis tools to share ideas and learn from each other. PyData communities approach data science using many languages, which include, but not limited to, obviously, Python, Julia, and R. So we do work in Scala and Java and other languages as well. And we also talk about things like Informatica and all. So for today, we have a great talk for you titled as Improving Your Python Skills with CodinGames.com. And I would like to give a brief introduction about our speaker, John Stinson, who's an active community member at PyData London. Currently, he's working at Barclays Investment Bank as a chief data architect. He has traveled to Pune several times and presented a talk in person at PyData Pune event in October 2018. So without further ado, I present to you John Stinson.
Great, thanks everyone. Really good to meet you. This is not your typical kind of PyData talk. What I found, when I've been speaking to Python developers and kind of reading the code, there's a lot of kind of tips for kind of improving, just normal kind of Python skills that you'd use to kind of collate your data. 80 to 90% of the work of data scientists is getting that data ready. And a few months ago, when we started lockdown, I came across CodinGame.com and HackerRank, started using them, and I found them brilliant platforms for improving my Python. So I really wanted to kind of share those experiences and share some of the tips I've learned. So what we'll be doing, we'll start with HackerRank and then move on to CodinGame. Now, let's try out the live comments. So if you've managed to have a look at onboarding yourself, or you've used HackerRank and or CodinGame, if you just put a comment in the live comments at the right of the screen, so we can get an idea of kind of who's used these platforms before. Okay, I'm not seeing any comments coming through, but let's go kind of from the basics. I'm going to share my screen now, and we'll start with HackerRank. If you've not yet onboarded, just try it in parallel with this talk. They've all the comments have just come through at once. Yes, use CodinGame. Yeah, use HackerRank. Excellent. Okay. So I'm going to attempt to share my whole screen. Okay, and before we even start going to HackerRank, let's talk about the Zen of Python, because there's 2 or 3 kind of bullet points in the Zen of Python here that I want to point out. One is readability counts, and the other is there should only be one, and preferably one, obvious way to do it, although that may not be obvious at first unless you're Dutch. What I found as I've kind of approached these exercises on these coding platforms is you tend to refine your code, and until you get to kind of one more obvious way to do it. And both of these platforms have methods for kind of voting up top solutions. So once you've submitted your working solution, certainly on CodinGame, you get to see other people's solutions. HackerRank, it's more of a kind of discussion forum. But either way, you get to kind of see other people's solutions, and you tend to find they all gravitate to a single way of doing things. That's the thing on the right. It doesn't always at first tend to be the most readable. So I've got these scales here. It's sometimes a balance between readability and the most kind of pure, interesting, concise way of doing things. What I have found is the more kind of you code, the more readable code gets. So code to me that when I first came across it was very difficult to read, and I found a lot easier to read. So I think readability also depends on your audience. So I just wanted to start on that point. So let's go straight into HackerRank. So when you come into the programming, both of these platforms, they're really interesting. They can prepare you for jobs. If you're a company, you can use both platforms for setting challenges for other people as well. So if you scroll down and just go to Python, we'll start with the basic exercises, because when I first went into CodinGame, I started with more challenging exercises, and I actually found most of my learning was from some of the simple ones. They're also a lot quicker to do, so you rattle through them a lot quicker. So if we start with just the most basic hello world, this is how the platform works. You get a problem, you've got to print hello world, you've got some discussion about it. Literally all you have to do here is add in there, and you've got your IDE, run code. That's working, so we'll submit our solution. It normally has some additional test cases when you submit, and then we've completed that challenge and we can move on to the next one. One thing to watch here, sometimes it gets set to Python 2 or PyPy2 or something. Just make sure this is on Python 3. Hopefully everyone's using Python 3 now. Other things to note on the screen, we've got, the leaderboard, everyone who's passed it gets equal top. You see your own submissions. So I've submitted twice. I submitted this one yesterday and a few seconds ago. And then you get some discussion. So on Hello World, the discussion is not that interesting. But you get that, and you also get a tutorial. So not many new tips to learn from Hello World, I'm afraid. But let's go back one step, and let's go to Python if else. Okay, so this is a more interesting one. Given an integer n, perform the following conditional actions. If it's odd, print weird. If it's even and in this range, print not weird. Okay, so we've got 4 different conditions. So let's go to the solution, and you can reset the code like this. First thing I'd notice, we're in Python 3, but there's actually a load of redundant code here. In fact, okay, so what we're doing here, we were setting n to this integer. So if I just do print n, now this is clearly not going to be the correct solution, but I just wanted to test we've got something that kind of works and actually prints the input value. Okay, so I've got an input of 3, I've outputted 3, so that's kind of working so far. But there's all this redundant code. So actually, I don't think I need any of this.
John?
Hey.
Yeah, sorry for interrupting. So if you can zoom in a bit. Like there
of course.
Yeah.
Is that better?
I think, yeah.
Great. Okay. Okay, so we've removed some code. Let's try running this. Okay, still the wrong answer, but we've outputted 3 still, so none of that code was actually required. How about this strip? So strip kind of removes any white space. If there's no white space in the input, we might not need that either. Does this work? Yeah. Okay, so that still works. So we've really reduced the amount of code there just by removing redundant code. And that was, I'm not kind of really particularly impressed with this exercise. Why even put that extra code in the exercise? Why not just simplify it to this? So that's the first tip. Second thing we notice is we've got all these conditions. So if we just implement these, let's have a look if I've got this code to save us. Here we go. So to save us working through all those cases in real time, I'm just going to paste this in. Okay, so does this code look okay? Let's just check. So our exercise says if n is odd, print weird. So that's saying if n is odd, so if when you divide it by 2, you get a remainder of 0. Sorry, you don't get a remainder of 0. Then print weird. And basically, it goes through each case, tests them, prints it out. So it's very readable. Let's run it, see if it works. Yeah, so both our test cases work. Let's submit it. When you submit it, you get some extra test cases, and they all pass. Fantastic. Okay, but it's a bit long-winded. So how could we simplify this? So we're saying if it's odd, print weird, or if it's even in this range, print weird. So I'm going to copy this code. We can look at simplifying the statements. So this is kind of just about kind of really working out the puzzle and thinking through the logic in a bit more detail. So here we've got if it's odd or in the range 6 to 21, print weird. So it's taking this case. So it's looking for both the weird ones. And then if it's not in either of those, then it must be one of the other two conditions. So print not weird. So let's try simplifying it like this. Okay, that still works. Submit it. Great. Okay, so we've halved the number of lines of code. But we can simplify it even further. And there's a shortcut for an if-else statement. So we can do print weird. Nearly there. For this. Great. Okay, so that's passed as well. So, you know, we've really simplified this problem. Now we can submit. So let's have a look at the discussions and see how well we've kind of compared with the other solutions on this one. Okay, so this person's defined a dictionary. So they've set true to not weird, false to weird. I mean, I think this is a bit kind of long-winded to me. They've left that strip in, which is not needed. So I think we've probably got a simpler solution than this. Let's have a look at any others. And this is, I spend more time kind of looking through these comments than I do solving the solution. So this is a nice one, but that's only part of the problem. Okay, so I can't see any kind of better solutions than ours at the moment. To be fair, I've already kind of run through some of these discussions before this session and just compared my answers to those. Let's see if we had any other tips from this one. Okay, this is this is an interesting one. So I did figure out a way to simplify it further, and that's using booleans as indices. This isn't kind of obvious at all. So let's go back to the platform. Here we go, and we're on the problem. So what we want to do is create a list containing weird and not weird, and then we can index that using a Boolean expression. And what we're going to use is the fact that a true evaluates to 1 and false evaluates to 0. So if this evaluates to true, we want weird. So we want weird to be our element number 1 and not weird to be element number 0. So not weird, weird. Okay, so this is where the readability kind of starts, it becomes a bit less readable until you get used to what this is doing. So you might not want to kind of take it this far. And I need to print it out. Okay, so that's passed. So let's submit it, check it passes all the test cases, and then we can just run through again how it works. So what this is doing, we've created a list, and we could use round brackets as well here. That could be a tuple containing not weird or weird, and this expression evaluates to true when we want the weird to be output, and when this evaluates to true is equivalent to 1. So it would give us the first answer here. So say use your own discretion whether you think this is kind of step too far in readability. I think it's kind of quite an interesting implementation. So that's the one I'm going to go for in this case. So I'm pretty sure we can't take this exercise any further. So let's go on to the next one. So we're going to have a look at this Python loops one. This is a really simple tip, printing a list over multiple lines. So let's go to the Python loops exercise. So you can just click on introduction here. Okay, again, we don't need this. We can simplify a bit already. This is our most. Oh, let me show you the use case. Really simple problem. If n is 3, you take 0, 1, and 2 and square them all and print them on new lines. So this is the obvious solution for. Let's call that I. Range n. Print n times n. You can use n to the power of 2. I just prefer n times n. It's one less character and just as readable. Okay, so let's check if I've got this right. Okay, there's a problem there because I need to do I times I, not n times n. Great. So we've passed that one. So there's a couple of ways of simplifying this. Well, or condensing it down to a single line. One is using list comprehensions. We'll mention list comprehensions later on. So you can actually put a print statement within a list comprehension. So we can do print I times I for I in range n. That takes it down to a single line. Great, so that one's passed. We can simplify this one further. It only uses n once. So why don't we just a bit of substitution? We'll come to substitution later on. I'm not sure why we've got these lines here that normally indicate some sort of problem, but I think it just doesn't particularly like that syntax. And this, it won't. Okay, this will work in a normal normal compiler. So let's take that one out again. There's another way of doing this as well. And that's using this separator. And list unpacking. So this is a list comprehension that's giving us the all the squares up to n. Really useful to get used to this star syntax. It's very powerful. So what it does, it converts this as a list and it converts it to individual values. And let's just illustrate that in a Jupyter notebook. I think I've got one open. Here we go. So if we do my list equals 1, 2, 3, my list, and then if we do star my list, it won't let me do it there. Let me just illustrate it using the on HackerRank anyway. Basically what this is doing is taking that list, unpacking all those values so you get the individual list. So it's just like printing 1, 2, 3, etc. And then this is a separator. So we're using a new line separator here. So if we run that code, that's another way to do it. So that works. I think I prefer the previous one, to be honest. So the previous one was slightly more concise, but this is useful syntax to know as well for new lines. Okay, let's move on to the next one. So that was tip 5. So let's go to write a function. Time, we get 25 minutes in. That's perfect. Okay, so this problem is to work out leap years. I hadn't kind of realized all this logic, but the logic they are looking for is if it can be evenly divided by 4, it's a leap year, unless it can be evenly divided by 100. So all the centuries are not a leap year, unless it's also divided by 400, then it is a leap year. And it wants you to put in a function. So it's taking the year as the input. You've got this function is leap, and here it's printing out the the result of the function. So this was, my first attempt at it. It implements the logic correctly. So if the year divided by 4 is 0, then it is a leap, and also the year is not divisible by 100, or it is divisible by 400. Hopefully that logic will work. Yep. So that's the logic that we're looking for. There's an obvious simplification here. I don't need to do this. It's true. This already evaluates to a Boolean expression. So this tip is just as simple as deleting these truths. And I've seen this in a lot of places. This already evaluates the Boolean expression, so you don't need to then convert it to a kind of true or false. So let's try this. Okay, so that works just as well. Let's submit it. Passes all the test cases. So yeah, simply removing the true and false because this is already a Boolean expression. Okay, and that's a really neat, simple implementation again. Okay, next one, inputs. So list comprehensions. Let's go to the next exercise. Okay, we're in the next section now. Here we go. So this is asking us to put a number of permutations together, but there was just, we're not going to do the whole exercise for this one. I just took a look at this and I thought that's a really inefficient way of reading the inputs in here. And again, I think it's bad because, really in these exercises, they should be kind of showing you some, neatly written code. So what you can do, because Python 3, you don't need that first thing. Actually, let's just print them out. Make sure the code still works. We'll run the code. Obviously, we haven't implemented the logic, so it's not going to pass the test cases. But we're outputting the same as the input, so that code is working. But we want to simplify this top bit. So the way I'd do this would be x, y, z, n equals, and then a list comprehension. So int input for, and this is another tip. I was going to put for I in range 4. Let's get that working first. So I'm going to delete this code. What that's doing is creating a list of 4 elements and then kind of unpacking those 4 elements into these 4 variables here. So that should give us the same answer as before, and it does. But that's not kind of perfect syntax. I is never used. So if there's a variable that's never used, you can just use an underscore for it. And it's clearer to read, because then you're not looking around for where else I is used. And this should return the same result, which it does. So we've condensed those 5 lines in the original example down to just a single line. Now, the other reason, sometimes it might not be quite as readable, but when you start writing kind of long code, so every so often, CodinGame will run a kind of global competition And in that global competition, you might be writing, I don't know, 300, 400 lines of code. If you've got, if you don't do this kind of condensing into a single line, you've got a lot of scrolling to do, and it kind of gets quite difficult to read through. So, if you think you might struggle to read this, you could always just put a comment at the end saying read for input variables. Someone else is reading the code as well, and it's still condense it down to a single line. There's another way of another kind of trick as well, or it's just another way of doing it. So rather than converting to int here, we could remove that. So here we've got 4 strings, and this is more like functional programming. So we can use the function map, and then int. And so if we want to do any pre-processing, this doesn't have to be kind of converting to an integer. We could write our own function to process each individual variable, and then just put the function name here, and that would apply that function to all of these input variables. So let's run that and see if that has the same result. Exactly the same. So using this map is a very useful technique to be able to apply functions across an entire list. And you can use it here again. If you're not familiar with the syntax, you might find it harder to read, but it's one of those things you kind of get used to, and you think, oh, that's a neat way of doing things in certain situations. Maybe not here, but if these inputs get more complex. We've got both of those written down. I will circulate a link to these slides afterwards. Finding the runner-up score. So sets, these are brilliant and not obvious if you're kind of new to Python. So let's go to this exercise. Okay, so what we've got to do here is print the runner-up score. So in this case, there's 5 scores, so it gives us the number of scores, and there's 2 people with a score of 6. So the first time I implemented it, I thought, well, the runner-up score is 6. The first score is 6. The runner-up is also 6, but it doesn't want that. It wants 2 equal firsts, and it wants the runner-up to be this score of 5. So it's looking for you to input this to output 5 here. So let's put a basic implementation in here. So we're using the same technique here that I showed you previously. So we're mapping a split input. So this is a series of strings. Oh, I think we should have another input here. Let me just, so you can revert to the original code like this. Yeah, we're missing an input. Okay. Use things like Shift Tab to outdent like a normal development environment, but this is missing a lot of the features of fully fledged development environment, which in a way kind of gives you more practice at trying to get things right first time. Okay, so here we're reading a string, which is a space-separated list of numbers. We're splitting that up into individual strings, and then we're mapping those strings to integers. We're taking the maximum value of the array, so this is just a list basically, taking the maximum value, and then we're using a list comprehension to remove that maximum value from the list. So if I is not a maximum value, then keep it in the array, and then we're printing the maximum of the remaining array. Okay, so that's a basic implementation. saying raw input is not defined. Do we just need to use input here? Have I got the syntax correct for raw input? Just go revert to the original and then got there. Okay, that's just using input. Okay, we've got an empty sequence. I'm not going to spend too long getting this working. I'm not quite sure what the there is. I'm sure there's something simple there. Let me just take you through the kind of the code here. So the point here is, and let me zoom in a bit. So this was our original implementation, and a neater way to do this is to get the unique values just using set. So it's could seem overkill, but we remove that duplicate 6 top score by converting it to a set. And then if we just remove that top score from the set, we can print the new maximum, which goes as the second highest score. I think this is a way neater way to do it. And then what we could do is use substitution to, to put this solution onto a fewer number of lines to, kind of make the overall code more readable. Another great thing in these exercises is to use sorted to find the second highest value. So again, if we take that set solution, and let me zoom in a bit. Then we can simplify it further. Here we're simplifying the entire problem onto a single line. So if we work from the inside brackets first, this map is just taking the that just gives us the input. So that gives us a list of the input values. We then convert it to a set. We then sort it in ascending order, and we take the second highest value from that sorted set. Now you can apply sort to a set. So sorted can take a list, it can take a set, it can take a tuple, it can take any kind of data structure that contains more than one value, and it will return a sorted list of those values. So I think this is a really neat way to do it. Once you've kind of seen this solution, on a single line, and you kind of work through it from the inside out, it's quite a neat way of doing things. Okay, so that's it for HackerRank. We've got 20 more minutes, and we're going to go on to CodinGame now. And I prefer CodinGame, and that's why CodinGame is in the title. So I started on HackerRank, got through some of these exercises, found them really useful to get some techniques, and then CodinGame, it's just a bit more fun. The test cases are progressive, so let's show you how that works. So we go to the so my avatar is Butterslide. If anyone wants to kind of follow me or whatever, you can kind of look up your avatars here at the top. Yeah, here we go. And then just click on them. And then you find something about them. So you can, I've spent quite a bit of time on this, kind of progressing through on CodinGame. It does get quite addictive. If you start off in the practice area, I kind of made the mistake. Well, I don't know if it was a mistake, but I kind of went in straight into some medium hard ones, and then spent kind of days kind of trying to figure them through. So just start on these easy ones. I find, I'm learning more from the easy ones than the medium or hards, because the medium or hard, it's you kind of get it into a very, very specific problem trying to solve that. But the easies you can kind of knock off in under an hour normally, and you get that kind of feedback on other people's solutions very quickly. So if you click on that to expand it, you'll see, I don't know, 80 or so different easy puzzles. These are the ones I've completed. We'll have a look at this rectangle partition one. And they're all, a lot of them contributed, but there's some really interesting kind of logic puzzles here. You can do Sudoku. This is probably, this one's got some really nice solutions using NumPy, for example. This one's a really nice one, encryption, decryption of codes, and solving puzzles, etc., solving games. If we start with just the onboarding, just to show you how the platform works. Classic puzzle. Solve it. Okay, so if you do this onboarding, it takes you through all the steps. You've got a little graphical thing, which is quite fun. What you've got to do in this one, you've got to shoot the nearest enemy to you. So you get 2 distances, 2 enemy names. You've got to shoot the nearest one. You choose your language. So we're going to do Python 3, and we literally just copy this code over here. Got it. Let's check the code, play test case, and watch the code in action. So you're seeing your code be successful in this little graphical user interface. You can full screen this. You can rewind it to see where you get bugs. You can pause it. So this is a lot more fun to use than HackerRank, I find. So if we move on to something a bit more challenging. Oh, by the way, so once you've submitted, so let's just submit this. Here you can just check the best solution. So this is where you get all the learning. So this guy, Bob, he's used, if you remember that technique we used before, which was Boolean indexing. So he's using this Boolean expression. If distance 2 is less than distance 1, that will evaluate to 1, which is true, and that will give us element number 1 in the list. And then there's, explanation here. Some people found it hard to understand that. So the guy who wrote it given some explanation, and you can upvote the best solution. So I find that really nice about the platform. So let's go to this rectangles example. Rectangle partition, the one we'll spend a bit of time on. We've just got 15 minutes left, so we'll run through this relatively quickly. So the challenge here is you're given a rectangle of width and height. Let me zoom in actually. Width and height. You're given some measurements on the width and some measurements on the height. So here we've got measurements of 2 and 5 on the x-axis and a measurement of 3. And what you've got to do is find all the squares here. So let's go to go to this deck again. So this tip is, when the problems start getting a bit more complex, just draw them out on paper. So I'm going to draw them out on screen here. This is the specification of the challenge. Now, the first thing I think we're going to have to do is, put the start and end values in, like this. So, if these are input as a list, then we want to extend our list to have on the x-axis 0 and 10. So tip number 1, we could write like this. We could have our input list of 2 and 5. We could have a list containing 0, and then we can start with the list containing 0 and extend it by adding the input list, and then append 10 on the end, and then we get the full list of values we want. That's one way of doing it. Quicker way is just use plus. So the thing to note here is, if you're using just the plus operator with lists, the things you're adding have to also be in lists. You can't just add a 0 to your list. It's got to be within a list. So that's a really neat way of kind of extend the list. So that's the first kind of part of this challenge. Now we've got to find the squares. So how do we do that? Well, we've got our X list and Y list. So really what we want to do is find the differences between all these combinations of points. So I suggest the first thing we want to do is, if we're starting with this list of X values, then why don't we try and find all the pairs? So we want 0 and 2, 0 and 5, 0 and 10, then 2 and 5, 2 and 10, and then 5 and 10, and then we'll be able to find the differences between those values. So finding combinations like this is tip 13. There's some great tools in a library called itertools that you can use to find combinations. You could, write it shorthand yourself. This code actually works. It gives us exactly the result we want, but it's really quite complex code. This is way easier. So if we just do combinations, and this will show you how the second argument is how many values you want in each tuple. So if you put 3 there, you get 0, 2, 5, 0, 2, 10, 2, 5, 10, etc. But we just want 2 elements in each one. So this gives us the result we need. So that's we're kind of nearly there then. Now we want to take this set of pairs and just get the differences. So there, a neat way to do it is with a list comprehension, which is tip 14. Hopefully everyone on the call is familiar with these. This is the longhand way of doing it, in a for loop. But with a list comprehension, you can do it in a very straightforward way. So putting all that together, let's copy this code. Oops, this code into our development environment, and I'll just explain how it works. So click on Solve It. Okay, so one of the tips we skipped was to add helper functions. This code here didn't come in the default thing, but what it did say, it gave you a tip on how to print debug output, and this is the way to do it. You use file equals sys.standard error. So I've written this helper function here, which will take any number of arguments and then print those arguments out to the command line. So we're taking the inputs, we're adding 0 and the width, as we said on our first tip, and then we're using this combinations, and then we're taking the differences, so we combine that into a list comprehension, and then we're finding the number of squares. So if I play a test case here, and that test case works, and it's scrolled off the edge of the screen because I've zoomed in a bit, but if I play all test cases, all of those will work. So we've got some working code now, but something I hate when I read code. I really don't like this code, and the reason why is because of this. We've got duplicate code, and the problem with duplicate code is, as your code gets more complex, you might want to refactor it. You might only remember to refactor it in one place. It's just horrible, to have to do things 3 times. If you need to update this, you've got to update it in 3 places. So the obvious thing to me would be to split all these duplicates out into functions now. So let's do that. Let's start with this first one. So these are just reading our inputs in. We can convert those to functions. So we create a function called getInputs up here, and then we just call getInputs. Sorry. We've got another opportunity here, so let's simplify this in. Again, so this is taking the differences. So if we create a function getDiffs, so that's the same logic, just wrapped in another function, and then we're calling the function here. But then we've kind of still got duplication. We're doing the same thing for the x and the y values. So because we've kind of simplified each of these lines, it becomes easier to remove duplication here. And in fact, what we can do is use some substitution. So we're just here substituting x list in and y list. So there's this kind of whole series of removing duplication and then substituting that helps clean the code up. So another duplication here, remove that, remove another duplication. Another substitution. So I'm skipping through here. And let's copy this code in. So this is way simpler. We're down to 1, 2, 3, 4, 5, 6, 7 lines of code now. And that still works perfectly. And that's all just simplification by, extracting duplicate code into functions and then substitution. So the only thing I would say here is don't necessarily overdo it. I really tried to kind of simplify this to the maximum, and I came up with this. This really is, not very readable. So that's probably taking it too far. So in the final 5 minutes, and as I say, I'll share these slides so you can have a go at these exercises offline and kind of work through some of the logic. I just want to take you through some of the other features on CodinGame. And what I said here, don't overdo the simplification unless you're doing a clash of code. So clash of code, these things come up every 5 minutes, and I've had a go. It's quite nerve-wracking doing it because you've got 15 minutes normally. It's either 5 minutes to do a simple exercise or 15 minutes. So if I go back to the start and you click on this compete button, you do these clash of code. So you click on here and then join a 5-minute coding battle. So as I say, they start every 2 minutes. As soon as they've got 8 people in, then the person who initiated the clash of code can start it. They're all quite easy exercises. So you might have to convert temperatures between centigrade and Fahrenheit and find the highest one. But this one I entered, I thought this was an interesting example. Like 50% of them are about reducing the number of characters in the code. Doesn't always make the most readable code. I can click on here and go to it. So this is one I entered, and this is my results. So I came 4th on this one. This is before I got the hang of it. I was really pleased that I submitted the first working answer. I got it down to 93 characters. And I thought I had a really nice solution. So this was my solution. And I kind of explained what it was. It was basically finding how many duplicates of a word there was within a string. So if I find my slides again, in fact, I can go to the view the code here. So this is my solution, 93 characters. I thought, oh, that's a brilliant solution. But yeah, there's a lot of ways I could simplify this. So for example, I've just got white space. I could remove this white space. I don't actually need these square brackets here for this list. So, you know, these are really interesting to do. So I refactored this last night and actually managed to get it down to about 76 characters, which would have won. But yeah, be careful on those exercises. They're really fun things to do and kind of really make you think about the optimal way to write some code. So it's Clash of Code. The other thing here that you can compete in is these challenges. So I entered the Spring Challenge. I actually surprised myself, did pretty well in that. The Spring one was Pac-Man. So you had to navigate a Pac-Man around a maze. It starts off really simple. So it gives you, has a built-in pathfinding algorithm. You literally can specify the coordinates of the power pills, just navigate straight the way there. So this is really easy to get started on, and it becomes more and more challenging. So they're really well structured exercises. So just to end on, I would just really encourage you, whatever your level is, to click on Fall Challenge 2020, join a fun and thrilling coding competition. No one has any idea what it's going to be about. Do a lot of practice in the meantime. Use this opportunity of kind of being in lockdown to have a go at some of these, and then you can use some of those techniques on this challenge. And if you're a reasonable developer, you'll do pretty well, and really help kind of improving your rankings, which then kind of become apparent to employees. I'm going to wrap up there, and if there are any questions, I don't know if we can kind of open those up in the last 3 minutes.
Hi, John. Can we hear?
I can hear you, yes.
Can we take a few questions?
Absolutely.
Okay. So there's a question by Tushar, and the question is very interesting. It is like writing in shorthand may use fewer lines, but compromises on readability aspect.
Yes.
Doesn't that make it complex to understand or debug?
Yes, it does.
If
It
it's
can
wrong.
make it more complex to understand. It depends on the level of kind of coders around you. If you're kind of entering a coding challenge or something like that, you're going to be able to read your own code. You know what level you're at, and you can read the code you've written. Particularly, it's kind of 1 week challenge. On the readability, it's absolutely true. We don't want to overdo it. So it's that's why I have those scales of justice at the start. It's a balance of readability versus kind of finding that really neat optimal solution. I would argue that code actually, if you condense it into fewer lines of code, then although that single line might not be readable, it becomes a lot easier to navigate through a 200-line program. If you condense 4 lines down to 1, and it's still pretty readable, certainly with grouping into comments, then you've condensed an 800-line program into a 200-line program. So you can get probably a quarter of your program on the screen at the same time, which makes that overall kind of readability and understandability of the overall code easier. So and it's about when you learn a new language, you might only know a small amount of vocabulary. As that vocabulary increases, then you can move from kind of understanding some exercise on a textbook to reading some really complex novel. So as your Python skills kind of progress, it will become more readable. But that's one of the hottest topics with these. I'd go for it's interesting what gets most upvoted. It's the kind of simplest, most elegant solutions that tend to be most upvoted by the community. So that's an interesting factor as well.
Yeah.
Great question.
So there's another question, and it is like, how do we decide best way whether to keep our code simple to read and understand or minimal? Also discuss about performance aspects for both.
Yeah, I don't think there's much in it in performance. Performance, performance certainly make use of some of the functions. I spend quite a lot of time on weather forecasting examples. And I've seen some examples where people have actually they've tried to rewrite pandas in basic Python code. And obviously Python itself is quite slow. It's the C++ libraries underneath, or C libraries underneath, that give it the performance. So really understanding those kind of Python functions and libraries and making use of that underlying C code will give you the biggest performance bang for the buck. And then I don't know, I tend to find the fewer lines of code I see, the simpler it is to kind of understand whether I'm unnecessarily looping through code, because the loops and print statements that actually cause performance issues. So, really look out for your print statements, particularly debug statements. If you've got slow code, start by masking or hiding or commenting out your debug statements, or putting a debug level indicator to only print out debug statements if you've got a flag turned on, for example. But again, great question.
Yeah. So there's another question, which is like, is there what is an ideal project structure for Python projects?
Structure in terms of classes or files, I guess. I'm guessing that's the question, but a lot of these exercises, that whole Pac-Man exercise, I wrote in 200 lines of code. I came in kind of like the top 5%. 200 lines of code you can do in a single file, and in fact these simple IDEs on CodinGame, etc., only allow you to use a single file. You can use an external IDE and then use more than one file externally and then condense the code and publish it to the platforms. But I haven't done that yet. I'm just using these files. When I started on these platforms, I did start using a lot of object-oriented code and create kind of more scalable code. But then I looked at some of these optimal examples, and what I'd done in object-oriented code, they'd done in 10 lines of code using a dictionary. And I found the non-object-oriented code probably controversially more readable. I'd say number one, focus on the simplicity. Number one, actually focus on the problem. Try and simplify the problem as much as you can. It's just by using paper and pencil. Number two, focus on the simplicity of your code. If you don't need to use object-oriented style, if you're not going to extend that code, maybe you don't need to. Maybe you can get away with simpler, more readable code just by using dictionaries and other constructs. And then as your code gets more complex, then kind of start thinking about wrapping it into objects, grouping it into separate files. But say you won't be able to do that on these code. You won't be able to use separate files on this coding platform. You can use object-oriented coding styles.
Okay, and one last question, which is, what tool would you suggest for code coverage?
Code coverage. We use it depends on what you use in your day job. I guess. So yeah, use your kind of company standards for code coverage. These coding game type platforms don't really emphasize you writing your own test cases. You can. If you go to kind of expert mode on CodinGame, you can add your own test cases in. They don't have kind of code coverage built in, but yeah, I'd use whatever your company standard is, and you build it into a continuous development pipeline. That's the other thing, and then use it. Whatever code coverage platform you're using. I've seen in a lot of cases the output just being ignored. I mean, I could go on testing for a long time, but another thing would be, don't focus so much on test scenarios for individual methods or on small lines of code. Look at coverage of your entire code base. The complexity increases as you start chaining methods together and getting classes to interact with each other. So run the entire application up and test all that interactivity between classes and methods. And by doing that, you'll increase the code coverage. And code coverage is not the only. You can get really good code coverage without really testing much. You've got to think of all the different scenarios within that coverage as well. So yeah, there's probably a whole session we could do on code coverage, automated testing, etc. Yeah, but again, great question. You should be doing automated testing. These unit test cases, they've got in CodinGame. They're really great examples because they get progressively more complex and they test some really good end scenarios. And they've also got kind of performance testing built into some of them.
Yeah, so I think it's time that we can wrap. So thank you, John. We are very grateful to you for sharing your time with us, sharing some cool tips and tricks and an impressive platform with a lot of cool coding challenges there. Thanks a lot to all those who have joined us live. This talk shall remain on YouTube. Thank you once again, and hopefully we'll connect with you soon. Thank you.
Thanks, everyone.